Time travel theories. Science versus science fiction. Time travel has fascinated humanity for centuries. The dream of stepping outside the ordinary flow of time, of revisiting the past or leaping into the future, has appeared in myths, literature, and scientific theory. It combines our curiosity about the universe with our deepest desires to undo mistakes, to see what lies ahead, or to understand the mysteries of existence. But what is the truth about time travel? Is it a fantasy that belongs to novels and movies? Or does science suggest that it might one day be possible? Exploring this question takes us through the realms of physics, philosophy, and imagination, where the lines between science and science fiction often blur. The roots of time travel go back to ancient myths. Cultures around the world told stories of people who journeyed to other realms where time flowed differently. In Hindu mythology, King Kakudmi visited the god Brahma. While the visit seemed short, countless ages had passed on Earth. In Japanese folklore, a fisherman named Urashima Taro spent what felt like days in a magical underwater palace. When he returned to his village, centuries had gone by. These tales reflect the idea that time is not absolute but relative, a theme modern science would eventually confirm. The modern concept of time travel began in literature. In 1895, H.G. Wells published The Time Machine, a novel that introduced the phrase time machine and inspired generations of thinkers. Wells imagined a device that could move its passenger forward and backward through history. The book was more than a story. It was a thought experiment about the nature of time and progress. Since then, time travel has become a staple of science fiction, appearing in films like Back to the Future, The Terminator, and Interstellar. These stories explore paradoxes, alternate realities, and the consequences of altering the past. While entertaining, they also raise questions that scientists take seriously. One of the most straightforward forms of time travel is into the future. According to Albert Einstein's theory of relativity, time is not fixed. It flows at different rates depending on speed and gravity. This effect, known as time dilation, has been measured in experiments. Astronauts orbiting Earth at high speeds experience time slightly more slowly than people on the ground. The difference is tiny, just fractions of a second, but it proves that time does not pass at the same rate for everyone. If a spaceship traveled close to the speed of light, its crew might experience only a few years while centuries passed on Earth. In this sense, traveling into the future is not just possible, it's already happening on small scales. Another form of time travel involves gravity. Einstein's theory showed that massive objects like stars and black holes warp space-time, bending the flow of time itself. Near a strong gravitational field, time moves more slowly. This phenomenon is known as gravitational time dilation. It means that someone who spent time near a black hole would experience less time passing compared to someone far away. The film Interstellar depicted this idea vividly. When astronauts visited a planet near a black hole and returned to find that decades had passed for others, while only hours had passed for them. This is not just fiction. It is a real consequence of relativity. While traveling to the future is supported by physics, traveling to the past is much more controversial. Relativity allows for certain solutions that seem to permit backward time travel. One such concept is the wormhole, a hypothetical tunnel through space-time connecting to distant points. If one end of the wormhole moved differently through time than the other, a traveler could step through and emerge in the past. Another theoretical possibility is the closed timelike curve, a path in space-time that loops back on itself. Mathematician Kurt G. Gödel described such a universe in the 1940s. While intriguing, these ideas face enormous practical problems, such as stability and the need for exotic matter with negative energy. The biggest challenge of traveling into the past is the paradox. If you could change the past, what would happen to the present? The classic example is the grandfather paradox. Imagine traveling back in time and preventing your grandfather from meeting your grandmother. If you succeeded, you would never be born, which means you could not have traveled back in the first place. These logical contradictions suggest that time travel to the past may be impossible, or at least restricted by the laws of the universe. Some physicists have tried to resolve these paradoxes by suggesting that time may branch into parallel universes. According to the many worlds interpretation of quantum mechanics, every decision creates a new reality. If you went back in time and changed something, you would not alter your own timeline, but create a new one. Your original history would continue to exist, while you would now live in an alternate universe. This idea eliminates paradoxes, but raises new questions. If alternate universes exist, could we ever travel between them, or are they forever separate? The idea of parallel universes connects science with science fiction. Many movies and books have explored this possibility, from alternate histories where events turned out differently to multiverse stories where infinite versions of reality exist. While we have no direct evidence of such universes, quantum theory leaves the door open. Some scientists argue that the multiverse is a natural outcome of our best models of physics, while others caution that it may be untestable and therefore beyond the scope of science. Another approach to time travel comes from the study of cosmic strings. These are hypothetical one-dimensional defects in space-time that may have formed in the early universe. If they exist, they could warp space-time in ways that allow closed time-like curves. The energy required, however, would be immense. Likewise, rotating black holes, known as Kerr black holes, might provide paths through time, but the extreme conditions would likely destroy any. These ideas remain speculative, highlighting both the creativity of physicists and the limits of our current knowledge. Philosophers also weigh in on time travel, especially regarding free will. If the future already exists, does that mean it is predetermined? If the past could be changed, what does that say about causality? Some argue that time travel undermines the very concept of choice, while others suggest that paradigms themselves are evidence that the universe prevents impossible actions. The debate touches on fundamental questions about reality, identity, and the nature of time itself. Psychologically, humans already practiced a kind of time travel. Memory allows us to revisit the past, reliving moments with vivid detail. Imagination lets us project into the future, planning, predicting, and dreaming. Neuroscience shows that the same brain networks are active when recalling the past and imagining the future. In this sense, time travel is not just a fantasy, but a core part of human consciousness. We live in mental timelines, constantly moving backward and forward in our thoughts. Despite the obstacles, scientists continue to study time and its possibilities. Experiments with high-speed particles confirm time dilation. Observations of cosmic phenomena reveal how gravity bends time. Quantum physics challenges our understanding of cause and effect. Each discovery brings us closer to understanding whether time travel is possible or forever beyond reach. Science fiction ensures that the dream of time travel remains alive. Stories allow us to explore the consequences of altering history, the dangers of paradoxes, and the wonder of seeing the future. They serve as laboratories of the imagination, where ideas can be tested before they are proven or disproven by science. From H.G. Wells to modern cinema, time travel has been a way to reflect on human hopes and fears. It is not just about machines or equations. It is about our desire to control destiny and understand existence. The true mystery of time travel may not be whether it is physically possible, but why it fascinates us so deeply. Time defines our lives. We are born, we grow, and we die, all within its flow. To escape that flow, even in thought, is to touch the infinite. Whether or not we ever build a time machine, time travel will remain one of the most powerful ideas humanity has ever imagined. What do you think about time travel? Do you think it's possible? Let me know and write it in the comments. It would also be cool if you could leave a link and subscribe. Thanks and peace.